kernel is really one monolithic system, one binary, but it's separated by subsystem, and certain subsystem definitely don't want the rest of the kernel see the internals of it. Like in this case, it's scheduler, so like structure run queue is the main data structure like within the kernel, and it's defined in this kernel sched.h file, and maintainers of it definitely don't want it exposed like everywhere else in the kernel. So, and it's optimized for like high performance, like certain fields, like it cannot be like really like rearranged easily. But what we need, like we wanted to inline some of the functions because they're in critical paths that need to access to this data structure. So the challenge here, we cannot expose the whole structure queue for the whole kernel because then, well, it's harder to like maintain and see like who's accessing what because like kernel is gigantic, millions lines of code. So what we want effectively is to have like private and public, like if C as a language has this feature where the same data structure can have a public and private view, what we could do, like keep this structure queue defined in sched.h and define like a mini public view into this structure queue that will have, let's say, like 1 or 2 fields. And then like the rest of the kernel can be compiled with this structure queue with a small 2 fields. Scheduler compile this, and then at the linking stage, those data structures that are looking at this public view would get adjusted to the private. So currently we did this workaround. So in the workaround looks like we compile a mini program main a.out small that like takes the offset off of the fields that we want. Then it generates pound define, and then we include this pound define where we need to. So it's like, it's kind of works, but really not scalable. So the idea here, add some attribute to this. And the nice part that we already have this attribute, like it's implemented both in GC and in LLVM. It's called this preserve access index. And the way it works, this field accesses, let's say it's like pseudo assembler here, like source register plus the offset. So this offset will be like whatever the constant offset from the beginning of the structure. But the compiler will also insert the relocation based on the type and will be emitted into ELF object file. So this feature already exists, like it's all supported by the GC and LVM, so through the both like front-end optimizers and the backend, but it only exists for BPF backend. So the proposal is to do this for x86 and ARM64. And the idea here that on the compiler side, it's pretty much very little work, just adding relocations for x86 and ARM. And the bigger part is the linker, because linker would not to do this like relocation and adjusting the offset, because half of the kernel we see structure in this case, in this like specific case, it will be like an NR pinned field, like 4-byte field. Instead of 0, it would need to be readjusted to whatever, 84 or whatever it will be in the actual like sched data structure. So there are, I think it's not hard to do, like but it's clearly the change to the C language, but we're of course like not going to ask C standard people because it will never happen otherwise. But it will be useful for kernel, and potentially this kind of feature may be useful for like libraries. When you have a library and you just adjust it on the fly, you have like one implementation like uses this library, but you potentially have like different libraries, and during the link you just resolve everything. So what people think? How crazy is this?
Not increasing the size, because if it's constant, you can say, well, it's 5, you just 5. It's not just increasing the size of the binary at the end. Because if it's constant, it's small, binary. Usually you have to, you can use
the whole
different...
binary size doesn't change. It's just like loads instead of whatever instruction that accessing the field, like instead of accessing it at offset that was like known, this offset will be like different during the linking. The instructions itself don't change. There will be no extra like load and store instruction. Only the offsets within this accesses will change.
Yeah, but if it's constant, must be bigger kind of. You have to account and change the instructions, so the code will use
doesn't fit
longer.
into like the immediate encoding within like x86 ARM or whatever. Like if it's it becomes from whatever 8-bit, doesn't fit into like it would need to do some use different instruction.
So this is like generalized core, right?
Yes. So that's what we saw. This is not like theoretical stuff. This is what like we're using on VPF side for views, like many. And on BPF set, we call compile once, run everywhere. And this is how it actually works. Like BPF programs compiled once, and then we load it on 100 different kernels, and all kernels have slightly different things inside. Because like one can be compiled, let's say, with debug information. When it's debug information, there will be like all sorts of things within data structure, like spin lock instead of 4 bytes will become a gigantic thing of 100 bytes. Like all the offset like in the kernel change, but the program doesn't care. Like it will, once it, during the load, this libpf, the loader, adjusts, like it knows here's a program and doing this relocation adjustment. So and it's working like quite well. This is how we keep like backward compatibility. Like pretty much like everything now in BPF land is using this.
So technically speaking, we have the passes in the backend at the moment in GCC.
Yeah,
which
GCC,
are doing
GCC
this.
has all of it.
Yeah, so it will
They
involve.
added support for the front end, like middle end knows not to screw it up. Back end emits it.
Yeah, but then will it be any chance of avoiding BTF and the BTF relogs, special BTFX relogs, and use else relocations instead somehow?
You can. The only question is how you encode this field. Like how, like currently it's based on type. So this is dumped from like this is BPF assembly, and this is description of the relocation. So all the information necessary to resolve is encoded in this relocation. So you can, of course, like extend elf, dwarf, whatever, use dwarf to do
Yeah, and this is the strings,
That's
right, that are actually encoding the ordering of the fields. That 0,
Yes.
1, 1.
Yeah.
Because you have to go by the BTF of the host kernel where you're actually loading
Yeah,
it.
currently it's all like BTF based, but BTF is not scary, just like a type format describing types in a C.
Yeah, but it is the BTFX, which is like the core relocation themselves.
but it's also like trivial. It's like
Okay.
string, so it's not fancy. And the logic is like not complicated at all. Like it's type, here's inner type, outer type, here's name. The matching of the types, like we tried like different things, like different approach, how like we find the candidates for types, especially like because we did it like a while back. Back then, like kernel had redefined types because there's Steven. Because he had defined ring buffer, structuring buffer for tracing for ftrace, which was different structuring buffer that was in the perf. So in the kernel, you can have like 2 different structuring buffers, and then like everything, like many like important data structure in the kernel, they were actually like forked, and eventually like we fixed it. But initially, like we had like all kinds of special logic because like whole kernel type system was like messed up, and the kernel was working kinda, but not quite well. Types were messed up.
So you have use cases for this on the kernel side, but on x86
so
or
this specific use case is what we did. So
Yeah.
this link to workaround that currently in tip 3. Peter Zylstra like couldn't think of anything better, but we discussed it on the list. But like, yeah, if this kind of feature was available, we could use it not only like in a scheduler, but many other things. Like even like within VPF, like we move certain like structures up into like public kind of domain, like in the top level like headers available to the whole kernel, only because we cannot do this like separation of like internal API versus public, and C as a language doesn't allow this. So like,
well, any opinions?
yeah, just a thought.
We will.
Maybe
we will sleep on it.
Prototype something on an LDM site and see how much people hate it.
Could this be used to do some sort of link time randomization?
Yes, yeah. That's obviously not the use case. Yeah, you can compile the whole thing instead of you can potentially like use it for security. Like there is a GC plugin to randomize structures.
Right.
So this can be like boot time. Imagine like you compile the whole kernel this way, and during the boot you decide which fields will be there, and just adjust whole fields across the whole kernel. Every boot you can have a different layout.
There is a little problem though that we also showing. Well, problem. I mean, in BPF Dorf is actually not used, but in other targets it is. So one thing that we thought that at some point was like, if you generate the BTF and you use the core, at some point the dwarf will get out of sync.
What do you mean? Dwarf? Okay.
The dwarf has information in it about the offset of the fields in the type
Oh, in that
structs.
sense, yeah.
So it will be it will be maybe some way to actually update the dwarf as well.
Yeah, but for like if it's used for security, like for randomization, you don't.
Well,
like I think the GC plugin that does this randomization it screws up dwarf as well. Like it doesn't care about.
no, that's one problem of that plugin actually. Yeah.
Well, security people might say it's a feature.
It's a feature.
But whenever you want to debug such thing, you can apply the same transformation to dwarf. You have all the information.
Well, but we need to do it at leak time.
Well, at debug time, you need to generate new updated dwarf just before. Yeah.
Have GDB, yeah. Well, yeah.
No relocation inside dwarf.
Sort of, kind
There
of.
are applications. Like
Just
dwarf.
copy,
There are-
copy
yeah,
and
there are
transform,
different
yeah.
things.
Okay. Okay, cool. Maybe it could work, yeah.
Anyway, just sieging the thought. Sleep on it.
Okay, thank you.